After a while of reading your own source code or reading someone else's source code, you will naturally start to wonder if there is a quicker way to find possible security vulnerabilities. The answer is yes, and it lies in automated source code analysis tools. After all, what is software for if it cannot do complex, repetitive mining tasks faster or more efficient than a human can? Automated code analysis is the process of using specialized software to read someone else's source code and point out possible security vulnerabilities for you to fix. Yes, I said possible. These tools only find possible problems. Automated testing tools comes into basic types of static and dynamic. We have already seen that static analysis, resource code, binary code, or byte code that are stepped that is not running as a program. Dynamic analysis today tools work by running the program source code and binary or byte code in memory, as it would when executing as a program. This allows the code to be run multiple times using different input data. This causes different execution paths within the program's logic to be tested or executed as a tester. As a software tester likes to see the tool is the most static and all dynamic code analysis tools that are automated in some way. The dynamic testing of software is just too complicated and complex of an operation to do manually. Besides, who doesn't like starting an automated program, going to lunch, and then coming back to find all the answers that have found out for you? After finding buffer overflows, most automated testing tools use input data testing. After all the improper handling of bad input data is most likely what will trigger an exploitable buffer overflow condition. Input testing is used to check how a program will handle both legal and illegal input values. The purpose is to determine if the program behaves correctly when given either good or bad input. If a program behaves incorrectly, a potential security vulnerabilities may exist, and that vulnerabilities might be exploitable to successfully attack a program and a system this program is running on. It is thereby extremely important that all programs handle input data properly and be tested that they do. And input testing, the ability to a program to handle several characteristics of input data are proven. Range testing is test data and input as a range of legal values, say 1 through 10. Any input outside of this range is illegal and should be handled properly and not considered to be illegal value. Input data may also be tested as a fixed set of input values. Using this data set, both legal and illegal input must be handled correctly. Input data can be restricted to a specific length of a byte characters, and passwords are often restricted to a length between 8 to 20 characters. Input data inside this range is legal and outside is illegal. Input data can also contain a legal set of required content, which we have all created password that must contain at least one upper and one lower case and some number. This and a number and a specific choice that set of punctuation characters. Input testing will check if all the legal characters inside of the legal character set are accepted and those characters outside are rejected. Finally, the input may be required to conform a specific data format, which data format either conforming or violating required data format, and this must be handled properly by the program. Input testing is a large set of range of input values can be extremely time consuming. Testing can use a minimal set of legal and illegal input values considered the minimal necessaries for input testing. For example, to test an input, the proper handling of a numeric input value is the range of 1 to 10. We could use the minimal test set containing the numeric value like 1, 5 and 10, the minimum and maximum legal values and illegal mid-range value. Of course, this range is so small that we can easily try out the possible legal values. But what about all the possible illegal values? Well, there is nearly a infinite set of those, which makes through testing extremely time consuming if not possible. We can use a finite set of illegal input values for input testing, but how do you know if the values you choose will catch any and all input vulnerabilities? Between performing minimal the set testing and a full set testing lies fuzz testing, also called fuzzing, when a set of possible input data is just too large to fully test or reliably test. Using a minimal set of data, a very large set of random data values can be automatically generated and used as input values. The fuzz can be random numbers, strings, or any binary data that vary in length, content, and format. The fuzzy input is literally a random input attack upon a program attempting to discover values that the program handed incorrectly. The high volume of input that may be generated require the fuzzing be performed using automated testing tools. Millions or more input tests can be performed depending on how long the fuzz test has allowed to run.